Okay, we're going to look at graphing a couple parabolas. The first thing is, how do you know these are parabolas? Well, if you look at them, and number 1 and number 2, there's only one squared term. So number 1, y is squared. So if you see y is squared, then you know this parabola is going to open either to the left or to the right. So it's going to look something like this or something like this. And if you see x is squared, that's what we know already, right? That's going to either open up or down. So it's going to look like this or like this. And I probably shouldn't draw those on the same curve, same plane, but we'll stick with that. What we want to do first is we want to solve for the non-squared term. So here we're going to solve for x. And here we're going to solve for y. So you're always going to solve for the non-squared term. So let's do that. So we want to solve for x, so we're going to divide by 16. So we get y squared over 16 is equal to x minus 2. And then add 2 over. So this gives me, I'm actually going to write it as 1/16 y squared plus 2 is equal to x. So this gives me this form here. If it's x equals, it's a times y minus k squared plus h. Okay, and in this form, where x is by itself and y is squared, hk is the vertex, which is tricky because it's switched from what it normally is, because x and y are kind of different than what they normally are. And then a is equal to 1 over 4p. This is something you will need to memorize and know. This is very, very important because that p will give us the focus in Directrix, which we'll talk about as we get there. But first, the parabola has a vertex, and so a vertex, we're going to look at the number inside the parentheses, which is 0, and then the number outside, which is 2. And this parabola has a vertex of 2, 0. You can also see this at the beginning if you look at the number that is next to x and y. So this would shift it right 2, and then the number that's next to y would shift it up or down 0. Or you may even pause the video and match h and k with the equation. Okay, so that's the first thing. Then after you find the vertex, you have to find p. So we'll say find vertex. And then we're going to find p. And this is confusing, and it's really tough to understand. It's not terrible just to kind of push through because it's this kind of simple algebra problem. But a is equal to 1 over 4p, so a is this number here. So 1 over 16 is equal to 1 over 4p. You might be able to look at that and see what that is, or you may need to cross multiply. We'll cross multiply just in case you don't see it. But you get 4p is equal to 16, and so p is equal to 4. This will give you what's called the focal radius, which is good to know, but this is just an important number. Okay, so now we're ready to start graphing, and we'll see why this number is important. So if I can draw a coordinate plane, let's see if I can get one that's somewhat straight. Then keep in mind, you got to keep in mind everything you know so far. So we know the vertex is 2, 0, so let's put that on our thing. And then I like to put a little v next to it just so I keep it straight. And I also know that this is going to open to the right. So how do I know it opens right? Well, y is squared, so I knew it was going to open right or left. And if a is positive, then it opens to the right. If a is negative, it opens to the left. So this guy opens to the right, so I know it's going to go this way. Because it opens to the right, if I count from my vertex, 1, 2, 3, 4, a distance of 4, that's the value of p, that gives me my focus. And so you could even, and we're just going to sketch these parabolas, or we're not going to have points on them that match. So as long as you have the vertex and the focus, that's good enough. And so my focus And so we'll go ahead and say find the focus. Is 1, 2, 3, 4, 5, 6, is 6, 0 in this case. And then the last thing we want to find is the directrix, and we'll talk a little bit about what this focus and directrix are. The directrix goes the other way a distance of p. So 1, 2, 3, 4, and it is not actually part of the graph, but it helps define the graph. And the directrix is the line through x is equal to -2 in this case. So the vertex is 2, 0, my focus is 6, 0, and my directrix is x is equal to -2. And so what is the focus and directrix? Well, it helps you define this curve. If you look at the focus and you were to count to the parabola, so 1, 2, 3, 4, and then if you keep going to the directrix, it's the same distance, 1, 2, 3, 4. And that's true for every point. So, and this isn't necessarily to scale, but if I had like some arbitrary point, this distance would be the same as this distance here. And so my parabola probably should be a little wider, it looks like, to make that true. But you'll see other illustrations that have that, or you look in your book, there's some good illustrations about what that is. But with the parabola, those are the things you need to know to find. You need to know find the vertex, find the find the vertex, find the focus, find the directrix, and then just know which way it opens, up, down, left, or right. Okay, let's look at one where we are